In this video, you're going to learn how to read Bitcoin transactions and how they actually work in a way that finally makes sense. By the end, you'll understand your own Bitcoin transactions, why multiple addresses appear on the sending and receiving side, and how to interpret transactions that you see on the blockchain. Before we break it all down, here's something that surprises almost everyone. Your Bitcoin wallet has addresses you've likely never seen before, and it's been sending Bitcoin to them automatically without you even knowing. Now, it may sound strange, but the idea behind Bitcoin's accounting model is actually very simple, and it works a lot like physical cash. Imagine you walk into a coffee shop. Your coffee costs $5, and in your wallet, you only have a $10 bill. You can't rip your $10 bill in half to represent $5, so instead, what do? You hand over the entire $10 bill. The cashier takes $5 for the coffee and gives you $5 back in change. Now, even though you only meant to spend $5, the whole $10 bill had to be used, and then you receive some change. Well, that's exactly how Bitcoin works. Let's say your coffee costs 0.001 Bitcoin, but the only Bitcoin bill you have is 0.1 Bitcoin, because you received this exact amount from a previous transaction. Just like you couldn't rip the $10 bill in half, your wallet can't divide Bitcoin you received from previous transactions either. It's like an indivisible digital bill assigned to your wallet address. So instead, your wallet spends the entire 0.1 Bitcoin, 0.001 is transferred to the coffee shop's Bitcoin address, and then 0.099 Bitcoin comes back to you as change in the form of a brand new Bitcoin bill. This change is sent to a new address your wallet creates automatically without you even knowing, and it's known as your change address. Wallets do this anytime you don't have the exact amount needed for a transaction. But sometimes it works the other way. Instead of having one Bitcoin bill that's larger than the amount you need to pay, you only have smaller bills that aren't enough by themselves. So let's go back to our cash analogy for a second. Let's say Bob gives you a $50 bill, Kevin a $100 bill, and Stuart gives you a $50 bill. Later that day, you go to the Nike store to buy a pair of Nike shoes that cost $180. So you do what everyone does. You combine enough bills to make the payment. In this example, you need to combine all three bills to have enough for the payment. So you hand the cashier the $50 from Bob, the $100 from Kevin, and the $50 from Stuart. That's a total of $200. The cashier keeps $180 and then returns $20 back to you as change. Bitcoin treats the amounts you receive from previous transactions similarly to cash. So let's say you previously received 0.5 Bitcoin from Bob, 1 from Kevin, and 0.7 from Stuart. These three amounts become three separate digital bills recorded on the Bitcoin blockchain, and each one is associated to the wallet address you provided the sender. In this case, you sent them address 1FBZ, 1LXP, and 1PZ9 to receive some Bitcoin. And so each digital bill is assigned to a different address associated with your Bitcoin wallet. Now, let's say you want to send 2 Bitcoin to Binance. You don't have a single 2 Bitcoin bill, so your wallet simply adds together enough Bitcoin bills from previous transactions to cover the transfer. In this situation, your wallet needs to reach at least 2 Bitcoin, so it combines all 3 Bitcoin bills you received from Bob, Kevin, and Stuart. It sends 2 Bitcoin to Binance, and because you didn't have the exact amount, 0.2 Bitcoin comes back to you as change. And as we covered earlier, your wallet automatically creates a new change address for you to receive that leftover amount. This is why you'll often see multiple addresses on the sending side and receiving side of a Bitcoin transaction. What you're actually seeing on the blockchain is your wallet gathering the digital bills you received in past transactions, using them to make a new payment, and then sending any leftover amount back to you as change. At this point in the video, you've seen these Bitcoin bills used in 2 ways. A bill large enough to make a payment, but then there's change, or multiple small bills combined to make a larger payment. And here's where the terminology finally comes in, because they aren't called digital bills. You see, every Bitcoin transaction has 2 sides, inputs and outputs. Inputs are the addresses the Bitcoin is coming from, and outputs are the addresses the Bitcoin is going to. And here's the key part. Every time someone sends you Bitcoin, the amount you receive becomes an output. Now, if you haven't spent that output yet, It's called an unspent transaction output, or UTXO. And this is Bitcoin's digital bill. It's also the name of Bitcoin's accounting system, known as the UTXO model. So if you receive 0.5 Bitcoin at address 1PZ9 in your first transaction, 0.1 at the same address in your second transaction, and 0.4 at address 1RK2 in your third transaction, that means you have 3 UTXOs available for you to spend. And your wallet balance is just the sum of all the UTXOs that are associated with your wallet. So there's no big balance stored anywhere. Your balance is simply UTXO1 plus UTXO2 plus UTXO3 and so on. In this example, your wallet balance is 1 Bitcoin made up of 3 separate transactions across 2 different addresses you generated to receive Bitcoin. Before we wrap up, there's one more thing to understand about real Bitcoin transactions, the transaction fees. The examples we covered earlier didn't include fees for simplicity, but in a real Bitcoin transaction, the sender pays a fee. The fee is based on how busy the Bitcoin network is, and your wallet will suggest the rate before you confirm the transaction. Once the transaction is created, the fee can also be calculated using a simple formula: the sum of all inputs minus the sum of all outputs. In this example, the fee is calculated by adding the 2 inputs, 0.5 and 0.6 Bitcoin, and then subtracting the 2 outputs. Now, whatever amount is left over becomes the transaction fee. And here's something else you'll notice in a Bitcoin transaction. The change amount often has more decimals than the destination amount. That's because the destination amount is usually a clean, rounded number that you typed in manually, while the change amount is simply what's left over after subtracting the destination amount and the fee from your inputs. This is why the change amount often shows up with more decimal places. And before we finish, there's one last thing worth pointing out. Some Bitcoin addresses start with the prefix 1, others start with 3, and others start with BC1. These are simply different Bitcoin address formats. Depending on the wallet you use, you might see one type or a combination of them. It really just depends on your wallet. I won't dive into those in this video, but if you want a breakdown of what each address format means, why they exist, and how they're used to trace Bitcoin, then comment below and hit subscribe so I know to publish a post or a video. Thank you for watching.